Hey everyone, and welcome to another deep dive. Today we're diving into something pretty exciting, something out of this world, you could say.
Haha, going for the lunar theme already. I like it.
You know me, got to keep it thematic.
Yeah.
But yeah, today we're talking about the technology that's going to be, well, cruising around on the moon for the Artemis missions. You know, those new lunar rovers they're building.
Oh yeah, we're going way past those grainy Apollo rover images you remember from history class.
Seriously, this is like comparing those to a Tesla or something.
Totally. It's the future of lunar exploration, up close and personal. And you're in the right spot because we've been digging into research articles, you name it, to give you all the details.
And let me tell you, this new rover is not your grandpa's moon buggy.
Not even close.
This thing makes the Apollo rover look like, I don't know, a toy car. It's true. And the approach NASA's taking is what I find fascinating. It's not just, let's build a new rover. It's like they said, hold my space snacks, watch this.
Right.
Pushing the boundaries of what robotics and autonomy can be in space.
Yeah.
It's like sci-fi becoming reality right before our eyes.
Okay, so let's break this down for everyone listening. First up, we got to talk about this thing called the Ground Test Unit.
Catchy, right?
Real catchy. Love the acronym, the GTU. So essentially, it's a prototype rover, but they're using it right here on Earth.
And it's not just sitting in a lab somewhere.
Oh, no, definitely not.
Engineers are suiting up, full spacesuits and everything, to put this prototype through the ringer at Johnson Space Center.
They're simulating lunar gravity.
The dedication is unreal.
Right here on Earth. Talk about commitment. But, I mean, I get it. Can't exactly send a tow truck to the moon if the real deal breaks down, right?
$1 million tow truck, at least. And what's really cool is NASA isn't building this all solo. They got these 3 companies, Intuitive Machines, Lunar Outpost, and Venturi Astrolab.
All big names.
All in this kind of friendly competition to develop the final rover design.
So it's like a space race, but like a friendly space race.
Exactly. Everyone wins if we get a killer rover on the moon.
With this competitive spirit pushing them, you just know these companies are coming up with some crazy innovations.
For sure, and that's where the GTU comes back in. It's the common testing ground for all 3 teams. NASA can compare the approaches, the tech, and make sure that final rover is ready for whatever the moon throws at it.
Smart. Okay, let's talk about this rover itself now. We're talking remote operation, different drive modes. This is some real high-tech stuff.
Self-leveling, which you got to have that on the moon. That terrain is no joke.
Which, by the way, just picturing it in my head, I desperately want to drive this thing.
It does sound kind of tempting, doesn't it?
Like a lunar dune buggy.
And we haven't even touched on the best part, the supervised autonomy they're building in.
Hold on, back up. Supervised autonomy, does that mean what I think it means?
You're thinking a rover that can kind of think for itself, right?
That's what I'm thinking.
You got it. This thing will be able to do certain tasks independently, which frees up those astronauts for what they're really there for. Science.
Like having a robotic assistant up there with them, which, speaking of, that's what makes this rover really exciting, right? It's not just about, I don't know, setting some lunar speed records.
No joyrides here.
This thing is a science machine.
100%. This rover is meant to gather data, and not just in a small area around the landing site like the Apollo missions. This time, astronauts can venture much further, exploring craters, highlands, those mysterious shadowed regions.
Ooh, you mean those places where we think water ice might be hiding?
Exactly. We're talking about potentially rewriting what we know about the moon's formation with the data this rover will help collect.
Okay, now we're talking. This isn't just a rover. It's like a mobile laboratory.
Yeah.
A time machine on wheels. Did I mention billions of years old?
You might have gotten a little carried away there.
Sorry. But it's just so cool. Imagine analyzing rocks that have been around for billions of years. Like they could hold clues to the origins of life itself.
Okay, so we're on the same page about how cool this all is. Now we got to get into some of the nitty-gritty details.
Right, of course. Like, we haven't even talked about the fact that it's not pressurized.
Keen observation. It's not like the Mars rover with its little cabin.
Right, not like that at all.
This lunar rover, no cabin. Astronauts are going to need those full spacesuits while they're cruising around.
So less RV, more like an ATV. That's got to make for an interesting ride. And a bumpier one than I imagined, honestly.
Probably a bit bumpier. But on the plus side, that design choice does make the engineering a bit simpler.
Simpler how?
Well, think about it. No need to build a pressurized cabin means less weight, a less complex design overall.
Oh, that makes sense. More room for all those important scientific instruments, too.
Exactly. They've still got the lunar lander for when they need a break from the spacesuits. That'll be pressurized, comfy, all the good stuff.
So the rover is about maximizing their time while they're exploring the surface. Got it.
Trade-offs. Right. A little less comfort for the astronauts.
For the sake of science.
Exactly. But a huge gain in terms of what they can actually do on the moon.
Okay, so less comfy ride, but way more science. I'm starting to see the appeal. This whole thing really makes it feel like we're on the edge of something huge with space exploration.
What do you mean?
I mean, it's not just about sending a rover to the moon, is it? This feels bigger.
You're hitting the nail on the head. This rover, it's a key piece of a much bigger picture, establishing a sustained human presence on the moon. Like, for real this time.
A sustained presence? Wow, so we really are talking about building an actual lunar base camp.
Yeah, a lunar outpost.
Like a sci-fi movie.
It's closer than you think. A hub for exploration, science, heck, even maybe resource utilization.
Resource utilization. Okay, now my brain really is going to those sci-fi movies. Are we talking about, like, mining the moon?
It's not as crazy as it sounds.
I mean, it kind of does.
I know, but the moon has some valuable resources up there.
Valuable how? Like, what kind of stuff are we talking about?
Things that could be super useful for future space missions.
Like what? Give me an example.
Water ice.
Water ice. Okay, yeah, that makes sense.
Helium-3.
Hold on, back up helium-3. What even is that, and why is it so important we get it from the moon?
It's an isotope.
Okay.
Super rare on Earth, but scientists think it's way more abundant on the moon.
And what do we do with it?
It could be used as fuel, but not just any fuel.
Don't leave me hanging.
We're talking fuel for future fusion reactors.
Fusion reactor.
An incredibly powerful and clean energy source.
Fusion-powered spaceships running on, what did you call it? Moon juice. Okay, you officially lost me. That's way too far out there.
It's true. And this rover, the one we're talking about today,
Right.
It could be the key to figuring out how much of this stuff is actually up there.
So the rover would be surveying, looking for this helium-3.
Exactly. Which then paves the way for those leaner industries we're talking about.
Mind-blowing to think that we're even having this conversation. But okay, let's bring it back down to Earth for a second, or, well, the moon. Even if we just stick to what this rover will be doing right now, forget about the future. The discoveries it could make are still incredible.
Oh, yeah, absolutely.
Didn't you say earlier that those permanently shadowed regions we talked about could hold, like, secrets about the moon's history?
I did. We're talking areas that haven't seen the sun for billions of years.
Billions.
Billions with a B. Imagine the kind of pristine samples that could be just waiting there. Lunar ice, evidence of the early solar system. Who knows, maybe even how water first got to Earth.
It really is like opening a time capsule from, like you said, the dawn of our solar system. But how do we actually get to that stuff? I mean, those areas are, well, permanently shadowed for a reason, right?
That's where this rover really shines. Think of it like a Swiss Army knife of science instruments. It's got it all. Drills to collect core samples, spectrometers to figure out what those samples are made of.
Spectrometers, those analyze the composition of rocks and ice. Right. We talked about those last month, I remember now.
See, you're a pro, and there's more. It's even got seismometers.
For moonquakes.
Moonquakes. You're on a roll.
So it's not just looking at the surface. It's like peering into the heart of the moon. This is wild.
We're going deep.
This is way cooler than those old Apollo missions. And speaking of cool, what about cameras? Are we going to get to see all this in high def?
Oh, you better believe it.
Please tell me it's got like a live feed or something.
Not live, but we're talking high definition panoramic views.
So I can basically pretend I'm riding along.
Almost.
Yeah.
You'll practically be able to feel what it's like to be right there with the astronauts.
Okay, sign me up for the next mission. Who do I got to talk to? But seriously, this technology is seriously impressive.
It really is. But it's more than just the tech itself.
What do you mean?
This rover, it's symbolic, of exploration, discovery, pushing the boundaries of what we know and where we can go. It's a whole spirit.
I can get behind that, for sure. So we've covered the science, the tech, those crazy future possibilities.
Physics life.
The astronauts. The ones actually going on this lunar road trip. What's it going to be like for them? It's got to be the experience of a lifetime for those Artemis astronauts.
Oh, yeah, for sure.
I can't even imagine.
Picture this.
Okay, I'm picturing it.
You're suited up, strapped in, ready to go, right? You climb into this rover knowing you're about to go further than any person has ever gone on the moon.
I'd be freaking out, I think. In a good way.
That's got to be a little nerve-wracking.
Totally.
But exciting, too, right?
Absolutely. But it's not just about the excitement, is it? It's about The data, the experiments, maybe even discoveries that change how we see the universe.
Right, it's both.
Yeah.
Adventure and responsibility all rolled into one.
The astronauts are like pioneers, huh?
Exactly.
Pushing the limits of what we know and what we can do out there.
And with that amazing rover by their side.
Speaking of which, can we talk about the view from this thing? Must be incredible.
Gotta be breathtaking.
No traffic up there.
Just lunar plains, mountains, and Earth hanging in the sky.
Wow.
Something most of us can only dream of.
I know I am now. This whole conversation, talking about this rover, the science, the future of space travel, it's left me speechless, honestly.
What's gotten you the most?
Just a sense of awe, I think.
Yeah.
To think about all the people who made this possible, the engineering, the planning.
Yeah.
It's inspiring.
It really shows what we can accomplish when we set our minds to something.
Totally. So to wrap up our deep dive into NASA's awesome lunar rover.
I'm sad it's over already.
Me too. But I want to leave everyone with this. What do you think will be the biggest discovery this rover makes? Will we find proof of ancient water on the moon, figure out how the moon was formed, or maybe find something completely unexpected?
The million-dollar question, huh?
Something that changes how we see the moon and maybe even how we see ourselves.
That's what I hope for.
Me too, me too. Thanks for being here for another deep dive, everyone. Until next time.